Start. Okay. Welcome to the Home of Science. As usual, this is the Katenda. Okay. So we have the question there on the board. So the question is coming from Science Paper 2. That is chemistry part, which is the 2021 internal section C, question 3. Okay. Let's get straight to the question. The question reads, study the following series of reactions for ethene. Okay, so we have ethene, and the series of reactions here they are for ethene. Okay, so let's study this series of reactions for ethene. Okay, so the same ethene here, it is reacted with bromine water in order to produce liquid F. Okay, the same ethene reacted with steam to produce liquid E. The same ethene also reacted with the excess oxygen and ignited there to produce gas B and the steam. Okay, and then from the same ethene, when we add gas A, it will produce ethane. Okay, and then ethane, they add gas C and the condition D to produce chloroethane. Okay, let's get to the questions. The first question, identify gas A, we also identify gas B, gas C, condition D, liquid E, and liquid F. Okay, so in order to identify these letters here, let's start from ethene. Okay, so the reaction of ethene, we know ethene is an alkene. So ethene, which is an alkene, only undergoes two types of reactions. That is addition reaction and the combustion. So this reaction here, which is giving us liquid F, it is addition reaction. The reaction which is giving us liquid E, it is addition reaction. But the reaction which is the reaction between ethene and the oxygen gas, this is not addition reaction, it is combustion. Okay, so we go to the first one. We identify gas A. Okay, so we know ethene is an alkene. So when gas A is added to this alkene, they say gas A, then it will produce ethane. So ethane there, it is an alkane. So this reaction whereby an alkane, in this case ethane, is produced from an alkene, in this case ethene, it is the reaction which we are saying addition reaction. So which gas must be added to ethene in order to give us ethane? It is hydrogen gas. Okay. So A1. So A1 we are saying it is hydrogen gas, and it is the addition reaction which we call hydrogenation. We call it hydrogenation because hydrogen gas is added to ethene in order to give us ethane. Okay, so we are done with gas A. We go to A2, gas B. Okay, so where is gas B? Okay, gas B is here. So it is the reaction of the same ethene. Now it is the reaction of ethene plus C, which is the excess oxygen. So this is the reaction where I was saying it is the combustion. Okay. So what does combustion produce under organic chemistry? Combustion under organic chemistry produces carbon dioxide plus C, water. So in this case, water has been referred to as steam. So steam is the gaseous water there. Okay. So now here they have said ethene plus excess oxygen, meaning it is complete combustion. So complete combustion produces carbon dioxide plus C, water. So gas B, meaning it is carbon dioxide, steam, which is in water there. Okay, so we move on to, we know gas E it is carbon dioxide. Since it is a complete combustion, they have said excess oxygen. Okay, we go to gas C. Gas C, where is gas C? Okay, gas C is here. So now it is from ethane. When they add gas C to give chloroethane. Okay, so what is gas C? C. Okay, so there we know that ethane is coming under alkanes. Now, alkanes, they don't undergo addition reaction. So if they add gas C, it is not addition reaction because they do not undergo addition reaction. Why? Because their combining capacity has been fully used. Okay? So which type of reaction is this where they add the gas C? So since they don't undergo addition reaction, the type of reaction there is the substitution reaction. Okay? So when they undergo substitution reaction, they do so with the halogens. Okay, so meaning gas C should be an halogen. Now what are halogens? Okay, halogens, these are group 7 elements. Okay, so now when a group 7 element is added here, we have been told that it will produce chloroethane. So just this name, we know chloro, it is coming from chlorine, which is a group 7 element. So gas C now we can say it is the chlorine gas. Okay, we move on to condition D. Okay, the same reaction where chlorine gas is added. So this reaction cannot happen in the absence of sunlight or UV light. So condition D, it is the sunlight or UV light. Let's just to shed more light there, we can say alkanes, their reaction, which is substitution reaction, cannot happen in the absence of sunlight or UV light. Okay, so we are saying we are saying sunlight, which is condition D, or UV light. UV light, same as sunlight, so UV stands for ultraviolet light. Okay, we move on to 5, which is B. 5, so liquid D, they are looking for liquid E. So where is liquid E? So the liquid E, it is here. It is the reaction of ethene plus steam. So what is steam? Steam, it is the water, which is H2O. Okay. So what type of reaction is this? It is also addition reaction. Now, alkenes, where this ethene is coming from, when they react with the steam, they form a compound known as an alcohol. Okay? So in this case, if ethene is used, it is reacted with the steam, meaning the alcohol that will be formed now, it is the ethanol, because they have used the ethene. Now, for example, if they had used propene, meaning the alcohol which was going to be produced there was going to be propanol. Okay, so since ethene was used, reacted with steam to give an alcohol, now the alcohol name will be ethanol. Okay, so that is it, liquid DE. We move on to 6. Okay, 6. They are looking for liquid F. So where is liquid F? It is here. So now this is now another addition reaction of ethene with the bromine water. This is actually the reaction which they use to differentiate alkenes from alkanes. Okay. So now when bromine water is added to ethene, then it gives the liquid DF. Okay, so bromine water meaning we have two molecules of bromine there, which is Br2. So when that Br2 is added to ethene, then it will give us the liquid DF. So there we have a compound by the name, which will go with the name 1,2-dibromoethane. So why that name? Because those two bromine waters, they are reacted there to the ethene molecule on the double bond, opening up that double bond, and then allowing those two bromine molecules to react with the ethene. Okay, so the name we are saying it is the 1,2-dibromoethane. Okay, so meaning the bromine molecule there, or the two bromine atoms there, they are at carbon number 1, also at carbon number 2. So we are saying since they are at carbon number 1 and 2, we need to even include those numbers in the naming. So we are saying it is 1,2-dibromoethane. Okay, we move on to B. Okay, B reads, write a balanced chemical equation for the reaction of ethene with excess oxygen. Okay, so it is this reaction with the excess oxygen. So the reaction of organic compounds with oxygen there, we call it combustion. Now we know that it will produce gas B and steam, and we already know what gas B is. So we say ethene. Now it is the balanced chemical equation. So we are saying we write the molecular formula for ethene, which is C2H4 plus, and then combustion with oxygen gas there. So we are saying O2 to produce what? To produce gas B, which we say D, carbon dioxide, plus C, steam, which is the H2O. Okay, so this ethene is in gaseous state, oxygen is in gaseous state, carbon dioxide in gaseous state. Also this one, since they have said it is steam, you can also say it is in gaseous state. Now we balance it. Okay, so how do we balance it? We balance the atoms on the left side and on the right side that they may be equal. Okay, so we have carbon 2, here it is carbon 1, so meaning we need 2 for carbon this side. Okay, so we write a 2 here, carbon balanced. Okay, we go to hydrogen, so we have hydrogen 4, but this side we have 2, so meaning we can also put a 2 here, 2 times that 2 to give us 4. Okay, hydrogen balanced. Now oxygen. Oxygen we have 2, but this side we have this 2 times this 2, which is 4, then plus this 2 times the 1 for oxygen there, which is 6. So we have this 4 plus this 2, which is 6. But this side we only have 2. So how can we get 6 for this side? Meaning we multiply with the 3. Okay, so there we have a balanced chemical equation for the combustion of ethene there to produce carbon dioxide plus steam. Okay, we move on to C. Okay, C. Give the structural, I think it was give the structural formula of liquid E. Okay, so we give the structural formula of liquid E. So E, we know it is ethanol. So we give the structural formula of ethanol. So before we do that, maybe we just write the molecular formula, then we get the structural formula from the molecular formula. Okay, so the molecular formula for ethanol, which is C2H5OH, and then from here we can get the structural formula. Okay, so we just say the structural formula, we write it this side. So what's the structural formula there? How do we do it? We start by connecting the carbon atoms. So we have two carbon atoms there. We connect them. Okay, and then we distribute the hydrogen atoms. We start with the first 5 there. Okay, so we have 1, 2, 3. Okay, so for this carbon we are done, meaning each carbon should have a maximum of 4 bonds. So this one has 1, 2, 3, 4. We go to the next carbon, also should have a maximum of 4 bonds. So already has 1, 2, 3. So we put the hydrogen there, hydrogen there. Now from here we are done with the first 5 hydrogen atoms. So which is 1, 2, 3, 4, 5, and then we have OH, which is the functional group for alcohols. So the OH should be here now. Okay, so that is the structural formula of ethanol. Okay, the last question here on top, okay, which is D, states the industrial application of the reaction of ethene with gas A to form ethane. So the industrial application of this reaction of ethene with gas A to produce ethane. Okay, so this is the reaction where we were saying it is the addition reaction, which is known as hydrogenation, because hydrogen gas is added, which is gas A, added to ethene in order to produce ethane. Okay. Now, what is the industrial application of this reaction here? Okay. So the industrial application of this reaction is that the same reaction is used to manufacture margarine from vegetable oils. Okay, so the same reaction here is used in the manufacture of margarine from vegetable oils by the process known as hydrogenation, which is the same process here, which is the hydrogenation. Okay. Okay, so we said used in the manufacture of margarine from vegetable oils by hydrogenation process or reaction. Okay, so that's it. Thank you for your time. You can invite more of your friends to subscribe to my YouTube channel. It is Katenda 94277 without giving a space there. You find me on YouTube channel there. If it is TikTok, you can still find me on it. You can find me on Home of Science. Home of Science, paper 2. So Home of Science. You can still find me there. So you just search home of science or home dot science dot paper 2. Then you'll find me there on TikTok. Okay, thank you for your time.